Alright, let's take a look at this problem. Maximum number of visible points. You are given an array of points and integer angle and location, where location is position x, y, and points I are in this form, x and y. Denote integral coordinates x, y. Initially, you're facing east from your position. You cannot move from your position, but you can rotate. In other words, pos x, y cannot be changed. Your field in degrees represent the angle, determining how wide you can see from any view direction. Let d be amount of degrees that you rotate clockwise. So we are on with the field of v of angle, d minus angle, like that, half of angle. So let's see. What is the degree? Is it 45? So the degree is given, right? Wait, what? So this is so. Okay. You can see some of the you can see some set of points if you for each point angle performed by the point you position in immediate east direction would form the position in your field of view. There can be multiple points at one coordinate. There may be points at your location, and you can always see these points regardless of the location. Points do not obstruct your view into other points. The maximum number of points. Return the maximum points we can have. Right. So first it says east, right? Where is that? Initially, you're facing directly east from your position. Okay, from position. So how do we get this area? How do we get that area? So if you know I actually don't know. I guess I need a hint. Sort the points by the polar angle and with with the original position, how you can consecutive collection of points will be visible from any coordinates. But how do I determine if I can see a point? Like that's the important thing. I don't understand that. Okay, I'm just gonna give a minute break. Maybe look at the formula of this. Okay, I'm back. So I just checked few solutions, but not in depth. I just saw that they are using some sort of math functions in Python. But yeah, like I said, I didn't go in deep. So let's think, how can we solve this problem? What do we need for this? So the thing here is that if we give different anyways, so these it starts it's the amount of degrees rotate the clock counterclockwise. Okay, counterclockwise. Every 1 minus half of the angle. So you always have the same degree angle, but you rotate, right? So if we have some sort of a function that checks the number of, if we check every possible angle, if we have like a, yeah, 360 followed with 360. Yeah, if we slowly rotate, then we have to compute everything again. But if we somehow sort the functions, not functions, but like their relative positions. So let's say that, okay, I have to draw this. So from the current location, I have to calculate the so like if I have this, if I'm at 1 1, and then I have like something here, it's like 3 2, right? So what's the degree here? So that's probably like 2 and 1. So I'm wondering this degree. Probably, right? I care about that degree because I'll be like my field of view is dependent on my angle. So I see this, say that this is x, right? So is this tangent? So what is, how do I find this degree? So I mean, I know that so cos Give me a second. If I take the differences, so tangent x equal to 1 divided by 2, right? So from how do I get my x? So let's see. Okay, maybe we have it here. Okay, so let's say that I have this like this 90 degrees, right? And at this point it is 2 tangent is 1. This I know that this is 45. My degree is 90, right? And then I also have like 3 something like that, and then 4 5, and then 4 4. And when I sort this, based on that, I will sort it in this order. But what are the constraints? So angle can be anything, the position can be anything between those, but it is positive. Okay, so it is always in this side. So it is always in this side. Okay, positive. So I don't have it here on these sides. So okay. All right. Then I'll just have these like that. And when I sort it, if I have 0 0 0 0, what's the tangent here? It should be negative, right? From here to there, it should be minus 1. And what's the thing here? This is 2 0. So here we see it, and it should be in between this. So I simply need everything in order. Everything. See that I have like 3 here, 3, 4. 2, 2, I have like 3, 4, something here. And I have 4, 3. This is in it, this is not. But for every one of them I have to calculate the tangents and maybe not tangent, but it should be probably tangent. And like here, let's say that I have this, all right? I'm gonna have x equal to 1 here, and I also have 90 divided by 2, which is 45. I take the tangent of this tangent, and this should be smaller than this tangent, right? Smaller than or equal to, so I don't have to compute this back. Okay, so okay, then okay. But in between that and minus this tangent, okay, so minus tangent x, it should be also greater than or equal to 45. Okay, let's try that maybe. For every so I have math, Python math tangent math 10. Okay, I can just do it like that. So if I have, okay, all right. So if I calculate for every points, for every x and y in points, if not if, but like we just calculate, I'm gonna have a like tangent array, which will be like this. Okay, and then here I'll just put everything in this, but I have to exclude the ones that are on my position. So if x is equal to my location, okay, I'm gonna have it like this. So my start, like origin x and origin y is equal to location origin y, origin r. So this will be 0 and then location 1. And here, if this is equal to O x and y is equal to O y, then we need the current, not current, but like these are the ones that are extra, and we don't want to count them. right? So else we calculate the tangent, or like, yeah, we calculate it and then put it in an array. So tangent array will be equal to, that's actually append, we'll just append the calculation here, which would be the first ones, x minus that divided by the other thing. So here it should be the x minus origin x divided by y minus origin y. Okay, and then we just have to count it, so we don't have to do it like this. And then here maybe like sorted, so that we know that they're we get the ones that are in the same. If they are in the same line, we just want to have them next to each other. So we probably want to go with sliding window approach. So tangent array sort. Maybe let's print tangent array. Okay, and here return 0. Let's see. Okay, this should be equal to 0. Okay, division by 0. Okay. Maybe if they are equal, so if x if y equal to all y, that means it is just maybe up or down. We just append so here we append 1, and also if x x minus o x is greater than 0, else tangent array append okay, let's do like this, and minus 1. Okay, let's try this. So okay, let's see, 2 1 should be 1. What's my origin? It's 1 1 1 1 1. Okay, so this is 1. Actually, wait, tangent 90. Maybe just put it. Okay, just a second. Right, it looks like there's a way to calculate this. Tangent array that depends. So we have this x minus x o x, and then y minus o y, and then this will calculate it and add it into that, and that will be our actually that will be our radian. So it's like here. So it returns between minus p and p pi. And yeah, knowing that, we can now use these to see if we can have 90 degrees in between. And how do we understand that? We actually add 1 to this, and we have that limit, the current limit, and then we go until we have something greater than that, and then we change our limits. We will have a sliding window approach, and the maximum is the answer, actually. So all right, so we basically have to perform a sliding window on this and then count the maximum number of elements we received. So for that, we simply longest like max points. So let's create that, and then here, and then now we have I and j, and for that let's see. Okay, it's just simple sliding window, right? So my current, it will always start with my current. It will always start with the current. So I get this, and then I'll go until I have 1 and 1.7878. So my current limits, the current limit is equal to 0. So I will have I, maybe also j equal to 0, while j is less than n, which is the length of tangent array. So here I will always increase j by 1. Actually, I'm not sure. So j. So first thing is that so we will have like a. So this should be I. This is j less than n. J. Okay, so my current limit will be my I, right? Tangent array I will be my current limit. I want to move from current position to until the end, until like I want to move like while my tangent array j is less than 1 plus my current limit. So it can be also equal. That is fine. So I go in, my limit is 0.78. I put 1. We just go until that point. And at the end, while doing this, I also increase my current count, which will be here, current count. Actually, it should be starting like 0 here. Maybe, yeah, it is current count, so it should be starting like this. And then current count should increase here every time they go in. And then, so we start with this, we edit, and then we go in this, we see that it is less than 1.78. I increase the count, again, I increase the count here, right? And then at the end, I check if current count is greater than the max points, max, so maybe I just do like this, max points equal to max points, and then current count. So we update it if it is necessary, and then what happens is that I increase my I, and then I again do the same thing, and but so what's the problem here now? So let's say that I have 2 at the end of this, okay? And here I go over it, and then I increase J, I'm pointing to 2 because of that. Now I increase I by 1, I come here, current count is 1. So, okay, let's see. So I should decrease the current counts minus 1 by 1 here. I shouldn't have it like that. So it just starts with 1. Now I have it. I increase it like that, and at the end I decrease by 1 because I get rid of this. I put this in the tangent area. Current limit is now that. Come here. The 2 is still greater than this, so we don't go in. And then when I go next I decrease count by 1 again. Come here. My current limit is now. Okay, actually, let's put 1 there. Like that, and then we go in, we increase the J by 1 and increase the count, which makes it 2, and then it just goes on like that. And then if you have like a 2.1, 2.2, 2.3, we add those, every one of those in, and then at the end I just increase I, and also here, by the way, this should be and J should be also less than n, because when J is at the end, we just stop. We don't even have to continue. So let's see. So since we start from 0, this should be 0. Okay, maybe try something else. All right. Okay. 3 3 1 3 3 3 4 1. All right. So sample 2 is not working. All right, and why is that? Let me put it in. And then 90, and then 1 1 1 1, like that. is expected to have 4. Okay, let's see. I'm at 1 1, 2 1, 2 2, 3 4, and 1 1, which is that's. So now the important thing here would be to, let me just print it here. Tangent array. So wait, I forgot to add the extra. That's the reason. Okay, just a second. Okay, so I'm gonna try these again. Okay, it is accepted. Let's submit it. Okay, we have a, oh, I'm actually returning something. So it returns 0 0. What is that? Wait, what's the angle here? Wait. Okay. Okay, I guess my limit is wrong. If my angle is 0, then it is of course 0 0 2 2. Okay. Um. So I'm always adding 1 here. Which is 90 degree, but I have to add math that tangent. Okay, well, that's current plus current. So that's my current plus the degree that's been given. So this is the angle. Okay, now. Okay, wait, what is this? Why is this happening? Oh, okay. So, all right. So what is math the tangent 1? 1.55 tangent 90. Wait, how do I get the radiant? Math radiant Python radians math radians Okay, let's try this now. Okay. Um. Okay. Hmm. So how many extras do I have here? And also like extra. Let's see. What's the extra there? Like maybe not printed or print this, and then if this is 3, I guess we don't have it. 64, 61, 94, 61, 94. Okay. So if it is equal to that and greater, we do it like that. Current limit is always the current angle plus tangent. We go like that. It can't be equal to that. We increase the count. We change the maximum point. We increase I. When it is negative, so if I print this, it's my output. It should be around 26. Well, I'm not sure. Yeah, it's been 42 minutes, but I think I got close. So let's take a look at the solution. By the way, let's think about complexity. So this is of n, number of points, and then we also have of p. Let's call it p of p. So because of this, it is of so the time times of n log n, right? And this is also time of n. And then of course the spaces of n. And when we go over it, we have sliding window approach, which is of n, but since we have sorted, it is of n log n and log n and so is that solution here. So we look at the angle like this. Well, actually, I made it. Okay, that was wrong, but here it is calculating the pi angle. It is calculating it. I use radians, and it is checking if the angle difference is like that. It is calculating the distance and then adding the to the answer. I'm actually not sure, but yeah, I will stop the video for now and look at this so that we will have a short video. I don't want to make this a long one because it's probably a simple mistake or something small. And yeah, for that, I'm just gonna pause now. All right, I found out the problem, which was here. Let me just show it to you. So this was the problem. I was always getting, I was getting negative values, and I had to also add the 2 times pi, multiply to the values so that I have always positive values. I'm actually like not that sure how that helps with the solution, but I think it might be related to the place where there's a change, like angle change, so that there are some positive and negatives in the sliding window, and that might be the reason that uh, I had like wrong output. But now it is working using this. I got help from this. Actually, here in the solution, I did a bit different than the solution. It is getting calculating the angle using pi and angle, and but here I'm using the array and also the radians of that angle. So I don't know. I thought that this is simpler, but here it is just doing its own calculation. But yeah, this is my answer to this problem: maximum number of visible points. And yeah, I'm just gonna close now. Oh, by the way, this took me like after looking at the solution, it took me like few minutes, yeah, maybe 5 minutes to understand the problem. And so yeah, okay.